This video is an introduction to complex numbers. Let's look at x squared equals -1. Because the square root of a real number is never negative, there is no real number x such that x squared equals -1. To provide a solution for these kinds of equations, mathematicians have invented the complex numbers. The imaginary number I, defined as the square root of -1, where I squared equals -1, is a solution of this equation. I is the basis of the new number system. So let's say we have the square root of -16, which we can write as the square root of -1 times the square root of 16. With I equals the square root of -1, we get I times the square root of 16, which is then 4i. We solved the square root of a negative number by defining I as the square root of -1. How cool is that? We can check this result by squaring 4i and obtaining -16. 4i squared equals 4 squared times I squared, which is 16i squared. And with I squared equals -1, we get -16. In general, we can write complex numbers as a plus bi. Like, for example, 2 plus 3i, 3 minus 7i, 3i, 5, 2 plus I times the square root of 2, or -3 plus 2i. Complex numbers are based on adding multiples of I to real numbers. A and B are real numbers. And I is called the imaginary unit. The real number A is called the real part, and the real number B is called the imaginary part of the complex number. Let's look at our examples. If b is not 0, then the complex number is called an imaginary number. An imaginary number in the form bi is called a pure imaginary number. So again, a, the real part is 2 in this example, and b, the imaginary part is 3. In this example, a, the real part is 0, and b, the imaginary part is 3. And in this example, a, the real part is 5, and b, the imaginary part is 0. Again, can you see that b in these examples is not 0? And because of that, these complex numbers are imaginary numbers. 3i is a pure imaginary number. By contrast, the imaginary part of the complex number 5 is 0. So the 5 is not an imaginary number. The number 5, or 5 plus 0i, is a real number. A complex number is simplified if it is expressed in the standard form a plus bi. If b contains a radical, we usually write I before the radical. Expressed in standard form, two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Let's look at the complex numbers 3 plus 5i and a plus 5i. For what a are these complex numbers equal? Feel free to pause the video and try it yourself. These complex numbers are equal for a equals 3. Both complex numbers have the same real part, which is 3. And both complex numbers have the same imaginary part, 5. So these complex numbers are equal. In the next video, I'll show you how to add and subtract complex numbers. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.